All right. Hello, Marika. Hello. How are you doing?
Hi, sir. Afternoon.
All right. How are you doing?
Okay, sir. How are you?
All right. Doing good. Doing good. Today we're going to be looking at first order differential equations. All right. So we'll start differential equation now. All right. So after we finish first order, Marika, only thing we're going to have left is second order and then probability to do. Yeah. So done, man. So first order today, they were done. Next week, second order differential equation. And a week after probability, then we're done. Can you imagine that? Finish up the topics then, right?
Yes, sir.
All right. So I already uploaded the notes. All right. And before we do first start a differential equation, I just want to show you where this comes from. So what I'm gonna do is I'm just gonna show you something that look a little bit nice. Look at this. Imagine if I give you y equal to 3x squared. How do you find dy by dx? Or dy by dx be?
6x.
dy by dx that would be equal to 6x. You're definitely right. Now look at this, Marika. If dy by dx is 6x, right? If I were to multiply x, if I were to multiply x times dy by dx, if I were to multiply x times dy by dx, right? And then I were to add it to, so x dy by dx, and then I were to subtract, let's say, 2y, that would be equal to 0, no? This would be,
X times 6x.
yeah, x times 6x would have given me 6x squared, no?
Yes, sir. Minus
And
2y.
and then I minus 2 times y, that would be 6x squared, no? Don't it?
Minus 2 times y.
Yeah, y is 3x squared. So 2 times y would be 6x squared.
Okay, I understand.
And then this would be 0, right?
Yes, sir.
So what I'm trying to say is sometime now they can give you this equation and ask you to find y. You see that crazy now? They can give you this and ask you to find y. Find the general solution of this. Find y. So if they give you this, Marika, and ask you to find this, what you're gonna have to do is solve what is known as a differential equation. So you can go from this to this by differentiation. All right, so let me put that down. We'll go from this to this by differentiation. But then to go from this, to go from this back to this, to go from this to this is going from this is the differential equation process. This is solving differential equation. You see what math's nice, Marika? Now we're gonna go the both way, solving differential equation. That's nice. That's
Yes,
nice.
sir.
Yeah. Yeah, man, you have to can know for the things two ways, solving differential equations. So that's what we'll be doing now. We'll be solving differential equations to find the general solution y. All right, that's what we're doing. Now, there are two types of first order differential equation. There's one called separation of variables, which we look at next week. And then this is known as, and then there's one called first order linear differential equation. Today we're looking at first order linear differential equations. To do, oh, by the way, Marika, in an exam, you'll never know which one of them you're supposed to use. They're never going to tell you that this is a separation of variable. They're never going to tell you this one is integrating factor. You're going to have to know which one is which, all right? So you're wondering, how do I know which one is which? Well, let's start talking about first order linear differential equation. So if it's a first order linear differential equation, it's gonna take a particular form. Let's look at that form. So first thing, Marika, is we need to know a definition of differential equation. Not that you'll ever get a test asking you what is a differential equation, but just so you know a definition. So what's a differential equation? A differential equation is an equation involving a function and its derivative. Let's say that one more time. A differential equation is a equation involving a function and its derivative. So look at this, Marika. The right here, so the function here, y, and so it's the first order derivative here, dy by dx. That is an equation involving its function and its derivative. When an equation having its function and its derivative, it's known as a differential equation. Is that understood? That's just the definition of a differential equation. Are we clear?
Yes, sir.
So now, Marika, a first order linear differential equation, observe, this one is the one that we're doing today. A first order linear differential equation is going to take this form. It's going to take the form dy by dx plus p of x times y. This shouldn't be a dy, this should be y. So it should be the first derivative dy by dx plus some function of x times y equal to a function of x, where p of x and q of x will be continuous function. We already know what's continuous function from module 2. This type of equation occurs frequently in various sciences, as we will see. We will see that in second order very soon. So, Marika, we're looking at first order differential equation, and it's very short. Like it's not even a 1 day topic, it's a 5 day topic. This is how we solve it. 5 minute topic, I should say. To solve a first order linear differential equation, first thing is that it have to be in this form. dy by dx plus k times y equal f of x. That is the highest power of the derivative is 1. The highest power of the first derivative is 1. So what are the steps to solve a first order differential equation? First thing, Marika, is they might give you the differential equation, but it's not in this form. So the first thing you need to do is express it in this form. dy by dx plus k times y equal to f of x. That's the first thing you need to do. You have to do that. Express it in that form, dy by dx plus k times y equal f of x. So what's the second thing that you do? The next thing that you do is to find the integrate factor, or some people might say integration factor, or the integrate factor. Find the integrate factor, and the integrate factor is calculated by e to the integral of k times dx. So whatever k is, e to the integral of this function right here will give you the integrating factor. The general solution will then be given by y times the integrating factor equal the integral of this function of x times the integrating factor that we found in step 2. Then step 3 is to just make y the subject. And that's it. Done this, so there you get your answer for y. Easy, soft. Now we're gonna do some examples only, and I made sure to put 4 different types of examples. This one involves sec, this one involves sine, this one though in standard form, we're gonna have to divide through by, and this one is just the easiest one. So we're gonna do all these 4 together. I will do 2, you will do 2. All right, and then that's it for first order. Right, and I won't even give a worksheet on this, because what I'll do is I'll give a worksheet combined on first order and second order. All right, so they get mixed up together. So I will do this one, and you shall do this one and this one. Okay, now maybe to be fair, maybe I do this one and this one, and you'll do these 2. There's a reason why I don't want you to start with number 4 yet. Have a little spice to it. So we're gonna do this one, and then you catch the principle of how we do it. All right, so the first question right here, it says, dy by dx plus 2y equal e to the minus x. dy by dx plus 2 times y equals e to the minus x. So remember, step one is to make sure it's in standard form. Step one, it should be in the form, it should be in the form dy by dx or y prime. I'm just gonna write y prime for dy by dx plus k times y equal a function of x. Is it in that form, Marika? Is it in standard form? Is it in standard form?
No,
Why is it not in standard form?
because is dy by dx f of x? Wait,
It is in standard form. This is y prime. Your k is 2. Y is y. Your f of x is e to the x. Why is it not in standard form? It is in standard form. So we now have to do nothing. Step one done already. Only thing we have to do is write down k. So we can write down say k equal 2. And then what is our f of x? Our f of x is e to the minus x. So yeah, it is in standard form. It is. F of x is e to the minus x. All right? Cool with that?
yes, sir.
Now that we know that now, step two. Step two, Marika, is to find our integrate factor. Find integrate factor. And remember the formula for integrate factor. The formula for integrate factor is, I like to call integrate factor I. Integrate factor I is e to the integral of k dx. E to the integral of k dx. So it's going to be equal to e to the integral of k is 2, so it's going to be integral of 2 dx. When we integrate 2, what we get is integral of 2 is 2x, so the integrate factor is e to the 2x, right? When you integrate 2, you get x, 2x, right?
Yes, sir.
So that's the integrate factor. Cool. Now step 2 done, Marika. Don't put no plus c yet, all right? Don't put no plus c for integrate factor. Step 3. Step 3 is you write the general solution. Or actually, step 3 is when you write y times your integrating factor. It should be equal to y times I is equal to the integral of f of x times your integrating factor. It's equal to f of x times I. That's what you end up get. This is what we get. And so now what we get now is y times our integrating factor is y times e to the 2x, y times e to the 2x. That's going to be equal to the integral of f of x, which is e to the minus x, e to the minus x, multiplied by your integrating factor of e to the 2x. That's what we do, multiply those two. So to multiply these two now, what we're going to end up get is y times e to the 2x. We can't simplify to just write back y e to the 2x. And that end up equal to e to the minus x times e to the 2x. When the bases are the same, what do you do, Marika? When the bases are the same, what do you do? You
You add them. You
add
add
the
the
pause.
pause.
So when I add the pause, what would I get? E to the minus x times e to the 2x. When
E
I
to
add
the
them,
minus x times e to the 2. So negative x plus 2.
which is just x, right?
Sir.
That's just x. Good. And when I integrate e to the x, I just get e to the x. e to the x, but then I put my constant plus c. All right, so this work out to be y e to the 2x equal to e to the x plus c. So then now, Marika, I need y to be the subject. That's step 4, make y the subject. Step 4, make y the subject. And it done this so. So making y the subject, what I'll end up get is y is equal to e to the x over e to the 2x, because I'm going to divide through by e to the 2x. When I divide through by e to the 2x, once the bases are the same, what do you do? What do you do when the bases are the same and you're dividing?
You minus.
You minus, so y will end up equal to e to the x minus e to the 2x is e to the minus x. So y work out to be e to the minus x plus c times e to the negative 2x. And that's your general solution. This is y. All right, this is y. That's your answer. Now what I'm going to do right now, Marika, is this is not part of the answer. This is just a proof of the answer or a check. So this would be the answer. Then they might ask, sir, so how you find C? To find C, they'd have to give you something else. They'll probably have to tell you that a point on the curve is ray. They tell you x equals 0 and y equals 1. Find C. All right? They'd have to tell you that to find C. So this is the answer, but look what I'm going to do just to prove it. So y is equal to e to the minus x plus c times e to the minus 2x. Now look what I'm going to do. I'm going to differentiate. So if I differentiate dy by dx is equal to e to the minus x, right? E to the minus x. When I differentiate that, I get minus e to the minus x. Then when I differentiate this now, I get minus 2 times c times e to the minus 2x. That's what I get when I differentiate it, don't it? Right? This is what I get.
Yes, sir.
Now look what I'm going to do. I'm going to add dy by dx plus 2y and it's going to give me back this. That's all I'm proving. So look at this now. If I were to add them, so if I were to add dy by dx plus 2y, dy by dx plus 2y, you'd end up realize that dy by dx is minus e to the minus x minus 2c times e to the minus 2x. And then I'm going to add it to 2y. So I'm adding it to 2 times this, which is 2 times e to the minus x plus 2 times c e to the minus 2x. 2 times e c, 2 times c e to the minus 2x. So if I were to add them now, look at this. So I add them, this and this becomes 0, right? And then 2e to the minus x and minus e to the minus x, that just become e to the minus x. So if you really look at it now, Marika, didn't you realize that dy by dx plus 2y end up equal this? End up equal this, no?
Yes, sir.
Nice. So you just have to remember the steps then. First, you make sure it is in standard form. Step 2, you find your integrating factor. Step 3, you write y times the integrating factor is equal to the integral of f of x times I. Step 4, you make y the subject. All right, cool with that? You cool with that? Are you hearing me, Marika?
Yes, sir.
All right, you ready for your question?
I'll try.
So let me show you about the question. This is your question. Go ahead and take this down. All right, go ahead. All right, so dy by dx plus tan x times y equals sec x. Yeah, that's your question. So I is equal to e to the integral. Rub out that, write down the formula. What is the formula for I? E to the integral of k dx.
That's how you'd write it, sir?
Yes, so e to the integral of tan x. Now, how do you integrate tan x? How we integrate tan x?
Is it integral of tan x? Is it cos?
No. So rewrite tan x as sin x over cos x.
Sin x over cos x. Would you get negative ln cos x?
Yes, negative ln cos x, which is just ln sec x. All right? Have to remember those things.
It wouldn't be negative
What happened to the e?
e to the ln sec x, is it, sir?
Yeah, e to the ln sec x. Okay. Then what happened to e and ln? What do you know
Please.
about e? What happened to e and ln? E to the ln of anything become what? You don't know?
Anything, sir?
All right, let me just show you something
Oh, so
first.
would it become what you put it to?
Yes.
So ln, it would be sec x?
Sec x, very good. E to the ln sec x is just sec x. All right, because e and ln are inverse of each other, all right? That becomes sec x, good. So that's step 2 out the way, I get I. What's step 3 now? Sec x times sec x, good. Don't put the square like that. Put the square before the x. It's sec square x. Yeah.
So does it matter, or does it?
Yes, it does matter. All right, that means sec square
So
x. When you put sec x squared, you're saying the sec of the x squared. So you square the x and then take the sec of that value. But when you say sec square x, you're saying that sec x is being all squared, or sec x is being multiplied by sec x.
so the only
All right.
time that you can have sec squared is when you have sec x times x.
No, that sec x squared just means the sec of x squared. So that's why I usually would recommend put a bracket around the x squared. But it's like you're saying the sec of whatever x is square of that. So you're finding the sec of the x squared. All
So
right, so
then
the next,
how would you get this then? So, because let's say you times it and you get,
if you times it, that would just be x sec x. X sec x would be what you write down there. Sec x times x is x sec x. All right.
x sec x. So
Yes, you just
there's
put
no
it.
way you can actually get sec x squared.
No,
Okay.
they usually give you that to differentiate. All right. What's the integral of sec squared? That's the integral of sec squared. Are you here numerical? What's the integral of sec squared?
Yes, sir. I'm trying to remember. Um, 10 x.
Tan x, yes. The integral of sec squared is tan x. All right. Tan x.
Do I have to put plus c?
Yes, plus c. All right. You don't finish it. Make y the subject now. But you don't finish it, you know. You have to simplify that. What is tan x over sec x? And put a line to border. Split the page in half. Yeah. What is tan x over sec x? They wouldn't give you full marks yet. What is tan x over sec x? What is tan x over sec x? What is tan x?
Tan x over sec x.
All right, what is tan x? Tan x.
Sine x.
What is tan x?
Tan x over sec x.
What is tan x? Just the tan x part. What is tan x part? What is the identity for tan x, Marika?
Sine over cos.
Yeah, exactly. That shouldn't take so long, man. That's supposed to be on the top of our head, sine over cos. All right. So write that tan x is sine over cos, and you're dividing it by sec x. What's the identity for sec x?
1 over cos x.
1 over cos x. You're dividing sine over cos by 1 over cos. So work out what that is. And then also multiplied by, okay, that looks good, yeah. Plus, what is, wait, you're not done yet, what is c over sec x? You not sure that part. What is c over sec x?
C times cos x.
C times cos x. So write it down, y equals sine x plus c cos x. That would be the answer. Right? Sine x
Y is
plus
equal to sine x plus c
cos
cos
x.
x.
Yeah. Plus c cos x. Alright? That looks good. That's the answer. Alright? Pull it down. Pull it up.
Yes, sir.
Alright. Alright, take down the next question now. This is another trig one. Go to the next page. dy by dx plus cot x times y equals sine x. Put a bracket around the cot x. We integrate cot x.
Do I put the plus c up here? Or does it matter?
No, you don't put a plus c there. When you find integrating
Is this
factor, you
correct?
don't put a, yes, that is correct. All right. What does that work out to be? E to the ln sine x.
Sine x.
Sine x, so write that down. where you integrate sine square x. Don't add 1 to the power, divide by the power enough. We know how to integrate sine square. That's crazy. You've never seen us do that. How do we integrate sine square x?
Sure. Would you try to rewrite it
We
in
use
its trigger
the,
identity form?
yes,
Or
trigger, you use an identity. Which identity are we going to use?
um, 1 minus cos.
No, we want to get rid of the power. We cannot integrate trig with power. We cannot integrate trig with power. We cannot integrate trigs with power. So we try to use an identity that don't raise to the power. So what are we going to do? What's the identity for cos 2x?
Cos squared, you mean cos squared x here?
What's the identity for cos 2x, the double angle, not cos square, cos 2x? The cosine of 2 times x. What is the identity for cosine 2x?
2 sin x cos x.
That's not the identity for cos 2x. That's the identity
Oh,
for sine 2. That's
sin
sine
squared
2x.
x. Sin squared x. Cos. So what time would we be finishing class?
We'll be
Today?
finishing very soon. We're going to finish very soon. After the next example. All right, stop worrying about what time we're finishing and try to
Sir,
remember what's the
is my
identity
mom
for cos
asking?
2x. Okay, come on. Let's focus now. Cos 2x. We'll soon finish after the next example. All right.
Cos squared x minus sin squared x, and then you have 2 cos squared x minus 1.
It is.
So we're going to use the 2 cos squared x minus 1.
No, we're not going to use that one. You see cos in the question? No. So which
But say
identity?
you ask it be which one, which you ask it be cos 2x.
Yeah, so write it down. Write it down on the screen. What's cos 2x? You tell me cos 2x is? How does that apply to the question now? You don't want nothing with power. So what I would do is rewrite cos square as 1 minus sine square. So write down the next identity for cos 2x. Change the cos square to 1 minus sine square.
It's 1 minus 2 sin squared.
Exactly, yeah, that's the identity. 1 minus 2 sine square. So now make sine square x a subject. Make sine square the subject, sine square x. That's 2 sine square x. Exactly, that's what we're going to integrate, all right? I'm not gonna lie, Marika, I'm a little disappointed we didn't see it right away, all right? Because in January, the second week in January, We looked at integrating trig powers. We looked at integrating sine squared, sine cube, cos squared, cos cube. We don't remember? And we did these with the identities, right? We can't forget these things.
So when you integrate cos, would you get sine, right? Minus, right, yes, sine.
The integrate cos against sine, yes.
Oh, so that's the times the a half times the constant as well?
Yeah.
Okay.
All right, now since you have half C, okay, when you finish, divide through sine first.
What did you say, sir?
No, when you finish.
Do can I divide through it by a half?
Oh,
Or
you want to make y the subject. That's always the aim, make y the subject.
okay.
Really? When you divide by sine, it becomes x over 2 times sine x. That's what it becomes, really? What's a half divided by 2? That'll be a quarter, don't it? So x over 2 divided by sine x can give you x times sine x over 2.
X over 2, you said, sir? Isn't it?
X over 2 divided by sine x.
Okay, okay.
X over 2 divided by sine x. What would that simplify to be? Write it this way and
It
another
would
page.
be,
Then x over 2.
oh, x over 2 sine x. Is
X
that
over
wrong?
2 sine x. Exactly, yes. X over 2 sine x. No, what is 1 over sine x, by the way? What's 1 over sine x?
1 over sine x, cos x,
1 over sine x is what?
cos x.
1 over sine is cos.
Yes.
1 over sine is cos. I'm going to ask you one more time. 1 over sine is cos.
That's what I said, sir.
No, 1 over sine is cosec. Cosec.
Cosec.
Reciprocal cosec. Yes, cosec x. 1 over sine can't be cos. 1 over cos is sec. 1 over cos is sec. 1 over sine is cosec. 1 over tan is cot. You have to remember them. All right. So that part, what they're expecting you to write now is, instead of when you divide through by sine, they're expecting to see x cosec x over 2. That's what they're expected to see, x cosec x over 2.
X cosec x over 2.
Yeah, so rub out the x over 2 sine x. They're expecting to see x cosec x over 2.
Where,
That's what
sir?
they
You said I should rub out? Here?
rub out the x over 2 sine x. All right, x cosec x over 2. I said x cosec x over 2, not x over cosec x times 2. X cosec x over 2.
Right here, sir? Not here?
I'm saying the x over 2 sine x, Marika, they don't want to see it dividing by sine x. They want to see you use the reciprocal identity. The same way, oh, in the question, give you a cut, and they didn't say 1 over tan. They want to say reciprocal identity. So x cosec x over 2. Yes, that's what they want to see for x over 2 divided by sine x. Good. Now let me see simplify sine 2x over sine x. What is sine 2x?
2 sine x cos x.
Exactly. So if you have 2 sine x cos x over sine x, what does that become?
So a negative a quarter, 2 sine x cos x over sine x.
Yeah. All right. So write that down and then cancel out what can cancel out.
That's not right, right?
No, that's correct. The signs them cancel. Sin x them cancel. Yeah. Plus what is now? C over 2 over sin x. When you divide by sin x, so it become 1 over sin x is what? And I said, Marika, they don't want to see nothing divide by enough sin x. They want to see reciprocal identity. What is that? C over 2 sin x. All right, good. So now write your answer, your final answer. How that become plus? What happened to the 2, Marika? What happened to the 2?
What you said, sir?
What
The
happened
two
to the
here?
2? The 2, yeah, what happened to that 2? I just the sin x them cancel. So 2 times a quarter is what? 2 times a quarter is what? Didn't we say the sin x then cancel? So we write back sin x. I just a half cos x. Exactly, that's the answer now. All right, that's the answer. Cool.
Yes, sir.
All right, you have one more to do. All right, this one is going to be real challenging. All right. So 1 plus x d times dy by dx. Put a bracket around 1 plus x. Dy by dx plus x times y. X times y equal e to the minus x. All right, go ahead now, solve that.
Sir, how would I do the 1 plus x that I
What
have
did
to
we
do?
what did we say? You must always try to put it in standard form. Dy by dx must be by itself. Or you get dy by dx by itself.
You have to divide it.
Divide everything by 1 plus x. Yeah. Now look how I want to write that. So I want to write x over 1 plus x times y. So put a bracket like x over 1 plus x bracket y. Now you know your k and your f of it. All right, now I want to say how you're going to integrate this. I equal here. Why is something here with the space? I can write it bigger. Yeah? We're going to integrate that now, Marika. How do you integrate that? It's not a formula to remember. I'm just asking what's coming to your mind. Just tell me what's coming to your mind. Can you hear me, Marika?
Yes, yes, sir.
All right, so just tell me what's coming to your mind when you look at that. It looked challenging, but what's coming to your mind?
There's does it have something with Ellen in there?
Okay, all right. I'm glad at least you see it have something with the alien code. So look what I want you to do. I want you to write e to the integral of, write this down.
In the
Right.
equal part or just as a no?
No, the equal part, under the equal part. All right. E to the integral of. So these things they have to be, write the integral sign bigger than man, stop screenshot the space, man. E to the integral of, you're gonna write 1 plus x minus 1 over 1 plus x. Now you make it look like the integral is in the numerator. Fix the integral sign and fix the e because now the e don't look like the power.
What was the top part, sir?
1 plus x, then subtract back 1. Isn't that the same as x over 1 plus x?
Yes, sir.
Yeah, so now look at that now, America, look at that. Can't I then separate that as the sum of two fractions? Write this down as a side note. Write this down. 5 over 7 equal 1 plus 5 over 7 minus 1. No, it's all over 7, not yet. 1 plus 5 over 7, everything over 7. Everything is over 7. 1 plus 5 minus 1 over 7. All right, that equal 6 over 7 minus 1 over 7. Isn't that true? That's true,
Yes,
though?
sir.
So look at that one we just here now. Separate it now as two fractions for me. All right, now what's 1 plus x over 1 plus x?
Integration.
No, what is 1 plus x over 1 plus x? What is 5 over 5?
Oh, 1 plus x over 1 plus x is 1.
Exactly, anything over itself is 1. So write that down. So that become e to the integral of. All right, now you can go ahead and integrate that. All right, so Marika, you have to always look out for them thing here. Sometimes you have to add one and subtract one. Maybe the next time you have to add five and subtract five. Maybe the next time you have to divide by a quarter and multiply back by a quarter. You have to look out for these things, all right?
Yes, sir.
How do you simplify that now?
X minus 1 plus x.
No, Marika, break it up as two different exponents. So that's e
Okay,
to the
okay.
x. Yeah.
Will it be e to the x
E to the x
over 1
times
plus x?
e to the
Or
x over e to the x times. If you have, write this down, e to the a minus b. What's e to the a minus b? What's that? Let me use a number then. Write down what's 5 to the 6 minus 2.
would it just be a minus b?
No, right? Use a number then, so you can use a calculator. 5 to the 6 minus 2. All right, because this is indices, not e. 5 raised to the 6 minus 2. 5 raised to the 6 minus 2. Put it in a calculator. What's 5 raised to the 6 minus 2? That's just 5 to the 4. How else they can write 5 to the 4? Isn't that 5 to the 6 over 5 squared?
So my calculator just does it.
Yeah, but look at this. Work out what? Marika, this is indices. I'm saying break this up using laws of indices. Isn't that 5 to the 6 over 5 squared? Check out that in a calculator now. 5 to the 6 divided by 5 squared. When the bases are the same, we subtract the powers. All they're doing is doing it the opposite way now. That's 5 to the 6 divided by 5 squared. Isn't that how you subtract the powers? Laws of indices? Don't it?
Yes, sir. So
Yes.
then it's e to the x over e to the minus ln x. No, sorry, my e to the ln
Yes,
1 plus x.
yes, exactly. Come on now, man. Yeah. Then what happened to e to the ln? E to the ln becomes what?
1 plus x.
1 plus x. All right, so that's the integrating factor. All them do a be algebra, they're saying that this is so easy. Just algebra. A lie? Maybe algebra this.
Yes, sir.
Yeah. So continue. What is f of x, Marika? F of x is not e to the minus x. You write it down, you know. You write down f of x. Come on, man. Why are you giving away your marks? The bases are the same. What you do? You
Oh,
integrate
what you said, sir?
e to the minus x times e to the x. When the bases are the same, what you do? Go
Oh,
multiply.
you add the power.
So add the powers then. E to the minus x plus e to the x, e times e to the x.
So it would be e to the 0, but
The
that's 1.
zero. But that's one, yeah. So that's become 1/1. One over
So would it become 1 over, what did he say, sir? I wasn't hearing you.
no, continue, continue.
So, sir, would it be 1 over 1 plus x?
1/what?
Is it 1 over 1 plus x?
When you multiply 1 plus x times 1, Marika always use numbers, you know. Write down 3/4 times 3/4. What would you get? 3/4 times 3/4. What happened to the denominator?
You just multiply them, sir.
You
And
multiply them. Say if you multiply 1 plus x times 1 plus x, what you get?
okay, understand. But I was wondering because when I add the powers, it 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 takes over where the e was. So it would have just been 1 over 1 plus x times 1 over 1 plus x. Is that how you'd write it?
I don't understand what you're saying.
Sir, when I add these, right?
You don't
Would
add them, you multiply them. You don't
sorry.
add
I
nothing.
mean
When
the
you
powers, sir. I mean the powers.
yeah, when you add the powers, yeah.
And I get I'm
1,
gonna get 1. So I'm
yeah.
saying would it be 1 over 1 plus x?
No, it can't be 1/1 plus x. You're not getting. How do you multiply fractions? You multiply their
So where does the
numerators.
1
Don't
go
skip any
then?
step. All right, follow what I'm saying. Write this down. Multiply two fractions. Write it as e to the minus x times. Don't put no times. You put a dot now or a bracket to show say you multiply them times e to the x over the 1 plus x times 1 plus x give 1 plus x squared. So let's put over 1 plus x squared. Now so work out fractions, not 1 plus x, put a bracket on 1 plus x, please. Now see work out fraction, you multiply numerators first, Then you multiply denominators. Then the numerator part simplify to be 1. Now see the
So it's
fraction.
just 1 over.
Yeah, 1 over 1 plus x all square. I just fraction this, you know. Don't make the whole heap of algebra frighten you. It's just fractions. How do you integrate that now? All right. So yeah, plus some constant. Okay, good. All right. E to the x over 1 plus x equal minus 1 over 1 plus x plus c. Okay, make y the subject now.
Sir, it would be negative 1 over 1 plus x times this.
When you make y 1 plus y the subject, you divide both sides by what? E to the x over 1 plus x, no?
Yes.
So divide it now. Just put divide over that. Divide e to the x over 1 plus x. Now simplify the division then now. Right, the same thing, so it's c times 1 plus x over e to the x. That's how you divide it, flip it, yeah. So what do I work out to be now?
So you want to show every step? Or I got it? Great.
You finish, I don't know which more step you're talking about. That's right, with y equal now. Negative 1 over e to the x. Don't write it like that. Write it as e to the minus x. Write it as e to the minus x. Remember, I said that they want you to use of reciprocal identities. Negative e to the minus x. Put back the negative sign in front of the e.
So you get it wrong if you write it like that?
Most times, if you leave it at that, you don't finish the full proof. So if you were at 7, you get 6 over 7. You don't get it wrong. You just don't get full marks. And let me tell you
So
how you know. Because if you look at the question then, they give you e to the minus x down. So when you're giving them back 1 over e to the x, if the question giving you e to the minus x, they're already telling you that if you buck up on 1 over e to the x, write it as e to the minus x. That makes sense? The
yes, sir.
question, if the question give you something with square root, don't leave the answer as x to the half. If the question gives you something with x to the half, don't leave the answer as square root. Does that make sense?
Yes, sir.
Alright, C, and I just said don't write e over e to the x. I just said don't write over e to the x and write it back.
So it should be, it would have been e to the negative x. C plus cx.
So write that, just write c times e to the negative x in bracket 1 plus x. That's all you have to do. You don't need to
What,
simplify.
repeat, sir? Wait. How did you say I should write it?
C times e to the minus x. Put a bracket now 1 plus x. You don't have to put a bracket around e to the minus x. Put a bracket around the 1 plus x. C times e to the minus x times 1 plus x. That's how you just need to write it. And you're done. All right, that's it. Cool with that? You understand
Yes,
why?
sir.
You understand why I can write like that?
I understand.
All right, so Marika, you have a lot of algebra to practice. All right, a lot of algebra. What I'm going to do is I'm going to upload 2004 to 2010 past paper. Why? You can practice those because those have a lot more manipulation of algebra. Because recently, Kate get a lot easier. That's why I don't like 2012, 2019. They're just so easy. But I'm going to upload a long time paper then. So you see more question you can practice with them here. All right. So you practice your algebraic skills. All right.
Yes, sir.
All right. So we're going to continue on Friday. We start in limits and continuity, which is module 3. And after the limits and continuity, we go back to locals, then we'll finish unit 1 because we'll do differentiation and integration already. All right.
Yes, sir.
All right. So take care, Marita.
You too, sir.
All right.